All right, I'm going to conclude the homework assignment on page 389 by doing the next 4 questions with you. So if you take a look at number 23, you see we have a rational exponent equal to another rational exponent phrase. And so it really is set up right now to remove that rational expression because we have radical or rational equal to rational. And now again, we're going to lift off that rational exponent by taking the reciprocal of the rational, which happens to be 2. And this, of course, cancels because half of 2 is 1, and that's the goal here, is to make that a 1. And this winds up being a fairly simple problem to solve. We have 7x plus 6 is going to be equal to 9 plus 4x. And now we can isolate the variable by subtracting 4x and subtracting 6, doing some multi-steps here. This gives us 3x equals 3, and x is equal to 1. And of course, it's always very important to go back up and check to make sure that your answer is not an extraneous solution. So let's go ahead and just do this mentally. 7 times 1 plus 6 is 13. 9 plus 4 is also 13, and they both have the same rational exponent, and so they do equal each other, so 1 is a solution. Let's move on to question number 25. As we do, we can see that it's not quite isolated to start, so we've got to pull that x over to the right-hand side, and then it is ready. Once we do that, we're going to square both sides. On the left-hand side, the radical is lifted. And on the right hand side, we've got to FOIL this out, and we're going to get x squared plus 2x plus 1. Again, another quadratic equation, and with quadratics we know that we have to pull everything over to one side and set it equal to 0. And we're going to get x squared plus x minus 6 equals 0. And this is a fairly easy factoring question. Those first two terms have to multiply out to equal x squared. The last two terms have to multiply out to equal negative 6 and also add up to a 1. So that, I believe, is going to be a 3 and a 2. To get a positive 1, you want a plus 3 and a minus 2. And now when we apply the zero product property, x can equal 2. That will make that grouping a 0, and 0 times anything is going to be 0, so that's going to be good. And then this one's going to give me negative 3. And as a result, now I've got to go back up here and check both my answers. 2 plus 7 is 9. The square root of 9 is 3. 3 minus 2 does give me 1. So that is a definite answer. Let's check negative 3. Negative 3 plus 7 is 4. The square root of 4 is 2. 2 minus a negative 3 is actually 2 plus a 3. That's 5, and 5 unfortunately does not equal 1. So that negative 3 is an extraneous solution. And so my answer is 2. Let's move on to question 27. Again, with 27, this time we have two rational exponents, and they are on the same side. So what we need to do is to set them equal to each other. Remember, rational, rational, or radical, radical. You have to set those equal to each other. And now you're ready to lift off that rational exponent by raising it to the second power, or squaring it. And when you do, the rational exponents disappear, and you're left with a very simple 3x plus 2 is equal to 2x plus 7. And now again, we can very quickly pull our x's over to the left and our constants over to the right, and that gives me x. These disappear, which is what I'd like for them to do, and I get 5. X is equal to 5, and let's just make sure that it checks out. 3 times 5 is 15. 15 plus 2 is 17. 17 to the 1/2. Now, in order for this to work, this also has to equal 17. 2 times 5 plus 7 indeed is 17. So when you subtract the 17 raised to the 1/2 minus 17 raised to the 1/2, you do get the 0. And our final question, number 29, is again, we have a rational exponent equal to a rational. It's ready to go because we have that rational equaling the rational. We're going to square both sides, and as we do, it just removes the powers there. We get 2x is equal to x plus 5. And once again, this is turning out to be a very simple question. And the final answer is x equals 5. And again, what we want to do is want to make sure that it checks. 2 times 5 is 10. 10 to the 1/2 power is what we have here on the left. In order for this to be equal, this also has to equal 10. And as you plug in 5, you see that it is. And so that is going to be a solution. And that concludes this particular lesson.